with sum of left leaves, it should be straightforward because it's easy, right? Find the sum of all left leaves in a given binary tree, okay? Given that there are 2 left trees and binary trees, return 24. Okay, so I think that, as with a lot of these tree type questions, I think it meant, as we can even see here, that you have a tree node definition, so it has a sort of I guess it's not actually super clear, but both left and the right of a tree node is another tree node, so it has a very recursive structure itself. So in general, especially if it's a Yeezy, unless you expect like a lot of like a long tree depth, we just do it recursively. Okay, so basically now, yeah, so given a root, maybe we, not sure we need help with variables, but okay. But let's say sum is equal to 0, let's declare that. And then, okay, if, so the recursion is something like we return sum of left leaves of both root dot left plus sum of left leaves root dot right. So that's kind of the recursion. Obviously, we only want to consider just summing it if it's a leaf first, and more specifically if it's a left leaf. So we might actually need to have a helper function here. I was a little bit lazy and then maybe trying to squeeze everything into one function, but yeah. So on the left leaf, and yeah, we might even get to do. Actually, we could maybe do another way as well. You do if root is none, then we just let's just say return silver now, because that's the root. And if root dot left is none, well, in that case, we just return sum of left leaves root dot right. Wait, so my case is wrong. Obviously, we also have to check that if root dot right is not none. And then another case is, I'm not actually sure I like doing it this way. There's too many if cases, but yeah, otherwise you actually maybe return 0 if both left and right is none. And you have to handle the case where it is the leaf. Okay, let me just actually create helper function. If that left, let's say self dot is leaf, if then something equals 0, then sum dot left dot well, and in that case, you actually could probably just do return the value on the left plus, and then sum of left leaves of the root dot right, and this should already be taken care of. Yeah, it was very distracting in here, but excuse me. Oh. Yeah, people are not commenting. Okay. Okay. So if the left, if that is not the case, then we just actually recurse on both left and right, which we already do. Does that take care of all the cases? let me see. Well, let's write the is the function. So that you know. And you just return no.left is no that right is none. Alright. Is this sufficient? This won't even need some. And eventually, every one of these will return root. So, okay, let me just run it real quick there. Oops. Oh, whoops.
Дима, на моей метке транспорт я бегу на там, где уебал чувака. Понял?
Just fixing some typos, some.
Да, вот там я чувака уебал, а ты бежишь.
And these are all object functions. So.
Там багет. Бля, чувак, дай мне коряк, бля.
Okay. Oh.
Мне больше
To record this with root is only. Okay. I guess my original intention is that no is not none. Wait.
Бля, ну там...
Let's see. If node is over, if node is left, then I guess.
Блядь, Дима, не делай так.
It doesn't really matter if node is none or not, but I think we need it here so that it terminates early. Whoops, that's not right. It's not none. Whoops. So many typos. Okay, so yeah, so that sounds like it's okay. Man, generally I do not like doing lead coding with tree stuff just because they have these array things where the 2n plus 1 and 2n plus 2 kind of thing. So it's kind of a little bit more annoying to test, but okay, well, I think I'm relatively confident. Let's submit this. Okay, so it got accepted, so that's pretty good. Yeah, I mean, I think with these ones, I think the critical part is just kind of make sure you're careful and make sure that you take care of all the edge cases. So there are a lot of random edge cases sometimes. This one maybe not so much, as long as you kind of just make sure you check it. I mean, there's the easy, so I think that's why I'm probably a little bit confident. I think if it was supposed to, I mean, and this is maybe a little bit meta, but if this was a little bit of a harder problem, I might consider, thinking about it a little bit more and just making sure that, I get the edge cases really right.